Hey everyone, today we'll continue talking about the simulation of the 5 degrees of freedom biped robot. We'll just start by showing what we previously did, which is basically just implementing a control system for the joints, as well as implementing a control system for the model-based gait algorithm, which was modeled on the spring-loaded inverted pendulum. All of what we did was input a location, for example 3, and we would have the robot move to a location which is close enough to 3 using a PID position controller. For this next part, which is the work that we recently completed, we implemented a step planning algorithm. So all of this is just basically deciding which foot actuates at the right time to achieve a longer travel distance. For example, if foot 0 starts the first step, then on the next step, once foot 0 lands on the ground, then foot 1 is the next foot to be actuated, and so on, just to achieve a natural walking gait of the biped robot. We had to make a few changes, which includes some of the forward kinematic model, since the whole system uses a different support leg. That means that the kinematic model is slightly modified due to that. And the code that we previously developed, we put it in a function which we call every time we want to move a certain distance. So essentially what we have is we start the code by setting all the parameters. So as you see here, we set all the parameters like the mass and the controller gains. And then we are in a while loop that is stopped by a condition where the condition is if the hip joint meets the desired hip position. And all of what we do here is just calculate which step goes first and by how much each step has to go to achieve a natural walking gait. So here we just call this function, which is the one we developed in the previous video. And we pass in the desired position as well as the foot which has to be actuated. So for example, if we want to move by a distance of let's say 4, so it should theoretically only take 1 step because the maximum step distance is 5. So here you go. The lines here that you see, the red and cyan lines, just show the trajectory of the hip, knee, and foot position. And as you see here, it is not labeled, but the blue line displays the desired position, which is R4 here, and the orange line displays the actual hip position. As you see, it does oscillate a bit, but with some tuning of the PID gains, we are able to achieve better performance. So let's try a longer distance. Maybe try 23, and it just computes. And here we should see the robot use both legs to move to the desired location of 23. So here we do get some oscillation, and notice it's just at the end, so I need to look into that. But as I said before, the blue line here on this plot display the desired position, and the orange line here display the actual hip position, which can also be seen here with the blue cyan. We observe the trajectory of the hip position. So here you go. And if I do click here, it's 22.9, which is fairly close to the desired position of 23. So we can also display another hip position. We can try, for example, 39 or maybe 43, whichever, and whichever desired hip position we put in, the robot hip position does converge to that location by achieving a natural walking gait using the spring-loaded inverted pendulum model. So yeah, as you see here, the robot completed its trajectory, and here you go. We reach 43.04, which is almost the exact same as this 43, so we are happy. And as I said, we are still getting a bit of oscillation at the end, but nothing to worry about. So here you go. This is our current progress for this simulation. The next step would be to implement it on an actual bipedal robot, and hopefully we'll have it work. All right, thanks for watching.